All right, we're going to look at the Bohr model of the atom here in this video. This is something you should have looked at your freshman year, so we're just going to kind of recap a little bit about how this model works and what it looks like. Okay, so as of right now, okay, your atom looks like a nucleus, okay, that has protons and neutrons in the nucleus in the center, and then you have electrons around the outside. We haven't talked about yet where those electrons are located. And where did Bohr's model come from? The Bohr model came from, he was looking at hydrogen's atomic emission spectrum and trying to decide how that came to be, how it came around. And this is an atomic emission spectrum. It has different colors. The emission one's on the bottom here. This is an absorption. Okay. And he saw these different wavelengths of colors we're going to look at, and he was trying to match up ideas for where these different colors came from. And he came up with what's called the Bohr model, because his last name is Bohr. Okay, so in this model, where are your electrons? Your electrons are located in set paths around, or orbits around the outside of your atom's nucleus. They have a specified amount of energy when they're in these paths, which is why you usually see it something like this. Okay, you have your nucleus in the center with the protons and neutrons, and you have your electrons in these set paths around the outside. All right, now we're going to look at these energy levels in particular. Okay, energy levels are the different levels around your atom that the electrons travel in. Okay, so these different yellow lines up here, those could be called different energy levels. And when we deal with energy levels, your lowest energy level is closest to your nucleus. It has the least amount of energy. Okay, all those electrons in there have the least amount of energy. So on this model here for aluminum, you have this first one here in green. That is the lowest energy level. That's the first one. Okay, anything further away is a higher energy level. So in this next energy level that has more electrons in it, that's a higher one. And then even more in this next one. The higher the energy level number, the further away it is from the nucleus. Okay, with these energy levels and how it's going to tie into an emission spectrum is that electrons can gain or lose energy, and they'll kind of move energy levels. So an electron can actually gain energy from something. Maybe you heat it up or give it some electricity or something like that, get it moving faster, and that electron can actually jump up a level or two. Okay, so this electron here might be able to jump up a level, or maybe this one can jump up a level, or maybe this one can jump up a level or two if you give it more energy. Okay, then the opposite happens if it then goes back to where it was or drops a level. So if it took energy for it to go from the bottom level to the next level, then when it goes back the other way, it loses energy. When it loses energy or emits it in the form of light. Okay, and the last thing are these problems with the Bohr model. Okay, what he noticed was that it didn't match up with the known spectrum for anything other than hydrogen. So we have these known spectra that they saw for these different atoms and these different elements, and it didn't work with any element that was greater than one electron, which is like everything but hydrogen. So it didn't quite match up with what it was, which means that electrons actually do not travel in orbits, and that your Bohr model is very wrong. It's just the easiest model to look at. This model was actually proven wrong shortly after it was come up with. He already thought it, or he came up with this, but it kind of holds out because it's the easiest way to explain electrons and where they're at. The next model we're going to look at is the quantum model at the end of the chapter, and that one's a lot more difficult to explain and a lot more difficult to look at with how electrons actually travel.